Structural Modeling 2.0 Part 2. So we're going to continue our exploration and demonstration of the JavaScript web app. This is an application of basic structural modeling and interpretive structural modeling. Again, the charts for this particular video are available at my website, which is here on this, and also this is a link to my Twitter feed. So we're working the 19 city problem. This is the progress we've made. We have 19 known cities. We know what those cities' objects are. We know the general relationship that we're looking for is north of. And we've collected empirical data points for 24 of those cities. We've performed the structuring operations among those that needed those operations. And we've inferred 19 new data points. So we need to gain more empirical information about these cities to go on and continue the structured process. The empirical data points that we've collected so far are listed here, and the inferred data points that we've inferred so far are listed here. So let's go to back to the structural modeling grid. Now this is where we left the state of the structural modeling grid at the end of the part 1 video. So we are now going to go ahead and start collecting more empirical information associated with this specific activity. So we have city 14 is north of city 13. So we'll just go city 14 is north of city 13. We'll enter that data. You can see that the green is in the lower section. So we'll go on and gather again more information now. City 10 is north of city 9. And city 10 is north of city 9. Enter that data. Now we have the one is in the upper, green is in the upper section, so we'll click on that. And then now we have all the ones that are in the lower triangular, the green ones which we know is true, the blue ones which we know are inferred. See if we can infer any more information. We can, we just inferred 2 new ones. Okay. So now the next set of empirical data is city 12 is north of city 17. Enter that data. You can see again the green's in the lower section. Then we'll have city 6 is north of city 1. City 6 is north of city 1. Enter that data. Again, green's in the lower section. See if we get any more inference here. Right, we did. We got another blue one down there. City 2 is north of city 16. Again, collecting more empirical data. So city 2 is north of city 16. Enter that data. Again, green's in the lower. Check for more inference. City 7 is north of city 15. City 7 is north of city 15. Enter that data. Again, the green is in the lower section. Then we'll gather more data on the cities. So city 18 is north of city 14. City 18 is north of city 14. Alright, we'll enter that data. Now we see we have a green in the upper section, so we'll move that back around. And then we can see we still have a green in the upper section, so we'll need to process that data. 14, so city 14 is north of city 2. So city 14 is north of city 2. We'll move that city data. Now again, we'll see that all of the ones are in the lower triangular, so we'll infer information. Got more information inferred there. So that was city 18 and 14. Let's check that. 18 and 14. Right, so that was that one. So now city 10 is north of city 11. City 10 is north of city 11. We'll enter that data. Again, green is in the lower section. And now city 10 is north of city 17. So we're going to go city 10 is north of city 17. We'll enter that data. Again, we'll see green is in the lower section. Now we'll go city 6 is north of city 9. Is north of city 9 here. Enter that data. Green is in the upper section, so we'll work that. Again, all the green now is in the lower section, so let's see if we can infer some more information, and we can. We got more inferred information there. That was city 6 and 9. So let's see, right, that's 6 and 9. So now let's city 2 is north of city 12. City 2 is north of city 12. Now we'll enter that data. See, the green is in the upper. Click on that. And we now have city 14 is north of city 2, so we'll need to process that data. City 14 is north of city 2. Move that. Again, now all of the green, all the ones are in the lower triangular section, the blue ones and the green ones. So we'll see if we can infer some more information. We can. We were able to infer quite a bit more on that one. And now we'll start taking a look at some directed information here, just to figure out which cities are going to give us the highest potential. So what we know when we're doing this is that we're going to have one city at the top that has all zeros, and then there's going to be one city with a 1, one city with 2 1s, one city with 3 1s, and so forth as we go along. So we can see here, let's find out which of these cities is going to have all zeros. So we have a 7 with all zeros, an 18 with all zeros, a 4 with all zeros, and so let's just get empirical information between 18 and 7. And in doing that, we find out that city 18 is north of city 7. So we'll put that information in. City 18, enter that data. And we can see now that the green is in the upper. So now that's been swapped. And then we'll see if we can infer more information on that. Then we can see that we have city 18 and city 4. So let's get some empirical information on that. And what we find is city 18 is north of city 4. So we have city 18 is north of city 4. Okay, let's enter that data. Green is in the lower section. So you can see we have now we have the top, we've found the top one because all the other rows have at least 1 1 in them. So 18 is the most northernmost city. So now we'll start working our way down through these cities and picking the pairs and getting the information we need to structure this process. So the next one we should look at really is city 4 and 7. They both have a 1 there. And what we find out is city 4 is north of city 7. See, we have city 1 here and a 1 here. So which is the most northern one? And we collect that empirical data and we find out that city 4 is north of city 7. So we'll put that there, enter that data, and we can see that the green is in the upper section, so we'll move that. And now we see that the city 7 is north of city 3, so we'll need to process that data. City 7 is north of city 3. Move that city data. Now we see everything is in the lower triangular section. See if we can infer. There we inferred more information. And that was 7 and 4. The next one we're going to look at here is 14 and 3. So we have 14 and 3. Find out which is the most there. And what we found out is that city 14 is north of city 3. So city 14 is north of city 3. And we'll enter that data. Again, we'll see that the 1 is in the upper section. Now, you can see that all of the 1s are again in the lower section. And now we'll take a look at what's the next one, 14 and 7, but we already know that so yeah, we'll take a look at 14 and 7 here and find out that city 14 is north of city 7. So we'll enter that data. You can see that the 1 is in the upper section, so move that around, and now we have everything in the lower. And now we'll take a look and see, and we'll need to get the information now on cities 2 and 3, the next sets here. 2 and 3, which one is north of the other, and we find out that city 2 is north of city 3. City 2 is north of city 3. Enter. Green is in the upper. Thing is in the lower section, so we'll do that. So the next ones we're going to look here are city 3 and let's say city 5. So and what we find out is city 5 is north of city 3. City 5 is north of city 3. Enter that data. See the green is in the upper section. We'll move that. Then we can see that we have to process this data here, which is city 10 is north of city 5. City 10 is north of city 5. And then we have city 12. City 12 is north of city 10. North of city 10. Move that data. Now we have everything in the lower triangular again. You see we're starting to fill this up as it moves forward. See if we can infer any more information there. Then city 5 and city 3. Yeah, city 5 and city 3, we'll ask about that, and we'll find that city 5 actually is north of city 3. City 5 is north of city 3. enter that data. The green is in the lower section. So the next one, as we take a look here, will be city 8 and city 3. And we find that city 8 is north of city 3. Enter. Green in the lower section. Next one, as we look through this, will be city 8 and 12, or be 8 and 12. We'll take a look at these, and we find that city 12 is north of city 8. Again, green's in the lower section. Now let's look at city 10 and cities 10 and city 8 right here. Look at these two guys and see how that works. And city 10 is north of city 8. City 10 is north of city 8. Enter that data. So green again is in the lower section. And then we'll look here in city 6 and city 11. We'll find that city 6 is north of city 11. Enter the data. It's in the lower section. Continue to look here. Now we'll look at city 11 and city 9. We'll find that city 9 is north of city 11. City 9 is north of city 11. Enter that data. So the green is in the upper section. Thing is in the... Now the next ones we'll look at are 11 and 13 here. And what we find is city 13 is north of city 11. And we will, green's in the upper section. So now everything's in the lower section again. It was 11 and 13, right. So now, next ones you look at are city 3 and city 6. Here's city 3 and city 6. And we find that city 3 is north of city 6. So we'll enter that data. Again, it's in the upper section. And then then they will take a next look at city 15 and 13. So 15 and 13, we find that city 15 is north of city 13. Enter. And we'll find that the green was in the upper section there. And we also find we have a couple of green ones here, so we need to process this data. And 13 is north of city 11, so we'll put that in there. 13 is north of city 11. That's city data. Here we have city 6 is north of city 9. So we'll have city 6 is north of city 9. Move that city data. Again, everything's in the lower triangular now. Now we're able to infer much more information. And so that was city 15 and 13, I believe. 15 and 13, that's correct. So now we're going to look at city 16 and 15. We find that city 16 is north of city 15. Enter that data. 1 is in the upper section, And now we need to process the data. We have city 15 and 13. So city 15 and city 13. Move that city. And now we have city 13 and city 11. Need to move that. City 13 and city 11. Move that data. Now everything's in the lower section. And that was 16 and 15. Now we'll look at 17 and 16. I love 17 and 13 here. And we find that city 17 is north of city 13. 17 is north of city 13. Enter that data. Again, we'll see the greens in the upper section. Then we have some data to process, which we have 13 and 11. 13 and 11. We'll move that city data. Again, everything's in the lower section. Next ones we'll look at are 13 and 1. And we find that city 1 is north of city 13. City 1 is north of city 13. Enter that data. Green's in the upper. Then we'll need to process the data with city 13 and city 11. Need to move that data again to 11. Everything's in the lower section. And then we'll look at city 19 and city 11. And we find that city 19 is north of city 11. And city 11. Enter that data. And we find that the green is in the upper section. So now we have everything in the lower section, and the system is essentially structured. So we'll continue this particular video in part 3.